going to do operations with radicals. Operations with radicals. All right. Hey guys, we're not talking to each other because it's my turn. Shh. Yes. Oh, a sharpener? Oh, they're up there. They're plugged in up there. All right. Operations with radicals. All right. So when you are adding and subtracting your square roots, cube roots, fourth roots, you basically need to have like terms, which means that before you can add them or subtract them, you have to simplify them, because you have to know, are they square root 2's that I'm adding together or subtracting? Are they square root 3's that I'm adding or subtracting? Are they square root 5's that I'm adding or subtracting? If we look at this problem, we have a square root 27 and a square root 12, and I can't subtract them the way that they're written right now. So I have to simplify it first, and then I can subtract them and see how many I have. So if I break down the 27, what am I going to get? 9 and 3, okay, and then I'll break down the 9. 3 and 3, okay. So I have a pair of 3's and a leftover 3. And so what does that make this become? Yeah, so I have the 3 in the front times the pair of 3's. And I have a leftover 3 that goes underneath. So my first expression, or my first term, is just 9 square root 3. Did I keep everyone with that one? Didn't lose anyone? Okay. Then over here we got to break down the 12. 6 and 2 is the first one I heard, but 3 and 4 would have worked as well. If I break down the 6, 3 and 2. Okay, so I have a pair of 2's and a leftover 3. So 2 times 2 with a root 3 left over, and so that's a 4 square root 3. Okay, I'm subtracting these. Now, because they are both root 3, these are considered to be like terms, and I can actually subtract them. If they weren't both root 3, then I would have to stop, and this would be the end of the problem, okay? But they're the same, so if I had 9 roots of 3 and I'm subtracting off 4 roots of 3, then how many do I have? Equals 5 square roots of 3. You wouldn't subtract the radicals because it's just like if you had a variable, it's just telling you what type of root you have. So I have 9 of them, subtract 4 of them, tells me that I've got 5 total. Yep, good questions. Okay, let's try another one. 3 times the cube root of 54 minus 2 times the cube root of 2 plus 7 times the cube root of negative 16. Ha-ha. I know, it got crazy out of nowhere. It's like, I think you can handle it or something. It's like, I believe in you. You're welcome. Whew. Okay, 54. 9 and 6. Okay. 9, 6. 3 and 3. 3 and 2. Am I circling pairs? No. I am circling triples. How do I know that it's triples and not pairs? I've got a cube root instead of a square root. Okay, so I know what you meant. It was a typo coming out your mouth. Okay. I've got a triple. I got a 2 left over. So I have a 3 in the front times a triple of 3s. So 3 times 3 is 9. Cube root the leftover 2. Okay. Can this one be reduced at all? No. Okay, so minus 2 cube root 2. Okay. Over here, what are we going to do with the 16? 4 and 4. Okay. Then what are we going to do? 2 and 2. 2 and 2. Okay. So we have a triple of 2s and a leftover 2. 7 times 2 is 14. We have a leftover 2. And how are we supposed to handle the negative? Do we put an I? No. How do we know that we're not supposed to put an I? It's a cube root, and with cube roots, you're allowed to cube root a negative. So with a cube root or a 5th root or a 7th root, you just take the negative and you just move it out to the front. So I'm going to take the negative, I'm going to stick it out here. So I have 9 cube roots of 2. I'm subtracting off 2 of them, and then I'm subtracting off 14 of them. Negative 7 cube roots of 2. Was the problem as bad as it looked? Because if you add a negative, it's just a negative. Good question. Okay. Let's try this one. We're going to do 7 times the 4th root of 48 minus 2 times the 4th root of 3 plus 3 times the 3rd root of 72. Okay. What do you guys think? What do we do? We said 16 and what? Oh, 6 and 8. 6 and 8. Okay. And then 2 and 3. 4 and 2. 2 and 2. Okay. Okay, and we're doing quadruples. So there's our quadruple and a leftover 3. And so what is this going to become?
14 quadruples square root.
Okay. So, and when we say this, we say 4th root. Okay, so 2 times 7 is 14. 4th root, 3. Okay. Minus, is there anything we can do with this? No. Okay, minus 2 4th root 3. Okay, and then what about over here? Nine and 8. Okay. 3 and 3. 4 and 2. 2 and 2. Okay. We got a triple of 2s, leftover 3s. And then we've got 2 times 3 is 6. Cube root what? 9. 3 times 3 leftover is 9. Okay. Okay, so our final answer.
Oh, wait.
So we're going to have two pieces at the end. Okay, but there is something we can put together. The 14 and the 2. Okay, so what do we get with that? 12. We get 12. 12. 4 through 3. Okay. And then plus 6 third root 9. We can't do anything more than that because we have two different types of roots. So no more simplifying. Yeah. Got to leave it there. Okay. Okay, let's do one that looks real funky. Okay, square root 98 x to the 4th y squared minus 3x squared y root 2. Okay. So 98 would be 2 and 49. 49 would be 7 and 7. Okay. So we have a pair and a leftover. How do we deal with the variables? We write them out. Okay, so we got 1, 2, 3, 4. And we got 1, 2. Okay. So now what do I do? So pair, pair, pair. Okay. So how do I write this down?
7 square root 2x squared.
Wait, what goes in the front? 7. Anything else?
No.
Any other pairs? X squared and y. Okay, and then what gets written underneath the square root? Just the 2. Okay. So 7x squared y times the square root of 2 minus 3x squared y times the square root of 2.
I'm lost.
What part is making you feel lost?
The line on the outside.
So anytime you have pairs, the pairs go on the outside. The only thing that goes on the inside is leftovers that are not part of a pair. So the x and the x were pairs, the y was a pair. We're not packing up yet. I still got a few minutes. We got to finish this problem.
I was about to ask, so if you had, like, for instance, 3 ones,
Uh-huh.
you took the pair out and you had the leftover, that's what
The leftover would have gone underneath, yeah. Now, what do you guys notice about all the stuff that's after the coefficient between these two terms? It's the same. So these two are considered to be like terms. You can simplify it. You've got 7 of them minus 3 of them, which means how many do you have? You have 4 of this mess. You have 4 of the x squared y root 2's. You have 4 of the x squared y root 2's, and then you can pack up. You can keep the sheets, or you can give them to me if you want me to hang on to them till Monday.